Hey guys, welcome back to Voltage Learning. Today we're going to be solving for the voltage across the resistor in the circuit R3 with two voltage sources, a 5-volt battery on the left and a 9-volt battery on the right. We're going to explore the node voltage method and break this down into 3 key steps. So let's get started. In step 1, we first define the node and ground. Let's call the bottom wire ground. That's going to be 0 volts. The junction between R1, R2, and R3 we'll call node A, and we'll call the voltage across this V sub A. Since R3 connects node A to ground, the voltage across R3 is simply going to be VA, and therefore that's what we want to solve for. Now in step 2, we're going to express the currents using Kirchhoff's current law. We need to identify currents I1, I2, I3, and write them in terms of Ohm's law. The first current I1 equals 5 minus VA over 100 ohms. The second current I2 equals VA minus 9 volts over 50 ohms. And finally, I3 equals VA over 100 ohms. These values come directly from the voltage sources or the values of the resistors. Finally, in step 3, we apply Kirchhoff's current law. The total current into node A equals the current leaving. Therefore, 5 minus VA over 100 plus 9 minus VA over 50 equals VA over 100. We can multiply both sides of this equation by 100 to get 5 minus VA plus 2 times 9 minus VA equals VA. Therefore, when we simplify this equation with a calculator, we get a final answer of VA equals 5.75 volts. Since VA is also the voltage across R3, we know that 5.75 volts has to be the voltage across the resistor. And that's pretty much it. If you want more tutorials or interview prep, visit us at voltagelearning.com and don't forget to like, comment, and subscribe. Until next time, we'll see you guys later.